Assalamualaikum warahmatullahi wabarakatuh. This is Group 1. We are CS110 students for MAT183 Group M3CS1103A. My name is Rizqin bin Nordin and my group members are Puteri Anura Binti Mohammad Nor Arifah Amirah Binti Arsat, Nor Hazwani Binti Mohammad Zulkepli, and Batrisyia Aleeyah Binti Mohammad Sophian. Our matrix number are as shown in the screen.
Assalamualaikum warahmatullahi wabarakatuh. My name is Puteri Anura binti Mohammad and I will explain about application of differentiation. What is differentiation? Differentiation is the process of determining derivatives or the instantaneous rate of change with respect to a function. Differentiation, on the other hand, may be accomplished using genuine algebraic manipulations, rules of operations, and knowledge of how to handle functions. Next, why do we use differentiation? We can find rates of change using differentiation. It enables us to determine the rate of change of velocity with respect to time, for example, which is acceleration. It also allows us to calculate the rate of change of x with respect to y, which is the gradient of the curve on a graph of y versus x. There are a few basic criteria that may be used to quickly discern a variety of functions. Question 1 is an inverted conical tank 20 meter high with a circular base on top whose radius is 5 meters. Water is running out from the bottom of the tank at a constant rate 2 meter per minute. How fast the water level falling when the water is 8 meter deep? So this is the diagram that we extract from the question. This is the radius, this is the depth of the water, and this is the height of the tank. This is the information that I have extract from the question, and the formula for the code is 1 over 3 pi r square h. So first we need to find the derivative of the formula. This is I have differentiate the formula, which is dv over dt equal to 2 over 3 pi r h. And then we substitute the information that we have, which is dv over dt is equal to 2 meter, and then r, we know that radius is 5 and the height is 20. Then we simplify, then we get 2 equal to 80 over 3 pi dr over dt. And then we need to find dr over dt, which is we need to move 80 over 3 pi to the left, and then we get 2 over negative 80 over 3 pi. Then we simplify, and we get negative 3 over 40 pi for dr over dt.
My name is Batrisyia binti Mohammad Sophian, and I'm going to solve for question number 2, which is a ladder 50 meters long pressed against a vertical wall if the bottom of the ladder slides away from the wall at rate of 1 meter per second. How fast is the top of the ladder sliding down the wall when the bottom of the ladder is 9 meters from the wall? The first thing you need to highlight all the important information in the question. The first step is you need to sketch the diagram and label all the dimension. The vertical line represented by wall, and the horizontal is the floor and also the ladder. Next, you need to extract the information and find the formula that relates to the question. So the wall will be represented by X, and the bottom of the ladder will be represented as Y. Next, from the question, it says bottom of the ladder slides away at rate of 1 meter per second. So our bottom of the ladder is y. So it's dy over dt equals to 1 meter per second. And also bottom of the ladder is 9 meter. It's y equals to 9 meter. We need to find what is dx over dt. From the diagram, you can see it is a triangle. So the vertical line is x, the horizontal line is y, which is equal to 9, and the slanted line is the hypotenuse, which is equal to 15. And to find the value of x theorem, which x squared plus y squared equals to h squared, and substitute dy and h. So the final answer for x is x equals to 12. The third step is we need to use the Pythagoras theorem, which is x squared plus y squared equals to h squared, to 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 find what is dx over dt. Then we need to differentiate x squared plus y squared equals to 225. Differentiate x squared, we will get 2x dx over dt. Differentiate y squared, we will have 2y dy over dt, and differentiate 225, we will get 0. Next, substitute our x and y and also dy over dt. Then we will get 24 dx over dt plus 18 equals to 0. Then 24 over dx over dt, and bring the 18 to the other side, which is negative 18. Then bring 24 to the other side, so it's dx over dt equals to negative 18 over 24. And simplify negative 18 over 24, you will get 3 over 4. And the final answer is dx over dt equals to negative 3 over 4 meter per second.
Assalamualaikum and hi, my name is Arifah Binti Arsat. My student ID is 2020613066 and I am from group 1. The statement problem is a cylindrical can without a top is made to contain 3 pi centimeter cubic of liquid. Given the radius is r and the height is h. From this statement, I can gather some information. The first information is we know that the shape is a cylindrical can without a top or cover, which means it is open. Second is the cylindrical can contain 3 pi centimeters cubic of liquid, and the last information is the radius is r while the height is h. Next, the question on A is asks us to show that the area is A equal to 6 pi over r plus pi r square. First of all, we need to find the volume of cylindrical by using the information given, which is 3 pi. So we are using the formula of cylindrical volume, which is pi r square h, and after substitute we can find that our h is 3 pi over pi r square. The second step is from the h that we get in step 1, we will substitute it by using the formula of cylindrical surface area, pi r square plus 2 pi r h. So A equal to pi r square plus 2 pi r will substitute with h 3 pi over pi r square, and after the calculation we will get that our A is pi r square plus 6 pi over r, means that this is shown.
Assalamualaikum warahmatullahi wabarakatuh, and hello everyone. My name is Hazwani Binti Mohammad Zulkepli. Okay, now I'm going to explain to you on how to solve the problem question B from the question 3. Now let's read the question carefully. The question is find the dimensions that will minimize the cost of the meter to make the can. In the previous, we already know that the family is pi r squared plus 6 pi over r. So we're going to differentiate it to get the first derivative. After we differentiate it, we get 2 pi r minus 6 pi over r squared. Now we're going to equate the first derivative with 0. We're going to move the negative 6 pi over r squared to the right side and the denominator r squared to the left side. And then we got r cubed equals 6 pi over 2 pi. Now we solve it. We get r equal 1.4422 centimeter. Now we already done for the first derivative. So now we're going to do the second derivative. How to find the second derivative? We're going to differentiate the first derivative. After we differentiate it, we got 2 pi plus 12 pi over r cubed. Now we got to substitute the value that we got from the first derivative, which is r equal 1.4422 into the second derivative. After we substitute, we get 18.8509. So that is the minimum value. So r equal 1.4422. Now to find the height, we take from the equation A in the previous, which is 3 pi over pi r square, and then we're going to substitute it into the r square. Then we solve it, we got 6.2398 centimeters. So that's all.
So, for question 4, we have a cylinder can is to be constructed with a volume of 16 meter cube. Find the dimension of the can with radius r and height h, which will have a minimum surface area. Give your answer correct to 3 decimal places. For step 1, we have the volume of the cylinder based on the question, which is 16 meter cube. The volume formula of a cylinder is pi r squared times h. So we'll make it equal to 16. We'll make h the subject, therefore h is 16 over pi r squared. Step 2. We'll use the area formula of a cylinder, which is 2 pi r squared plus 2 pi r h. Substitute h with 16 over pi r squared, which is over here. We'll substitute it with the value from here. Now, once we have our value 2 pi r squared plus 32 over r, we'll move r from the denominator to the numerator to make it easier for our next step. Our next step, step 3, differentiate the area. We'll put equal at the back so we could find the value of r. So we'll move negative 32 over r squared, which will become positive. And then we'll move r squared, which becomes r squared times 4 pi r becomes 4 pi r cubed. And then we'll move 4 pi becomes 32 over 4 pi. And then we'll move the power of 3 becomes 32 over 4 pi square root of 3. Then we'll get the value of r, which is
Assalamualaikum warahmatullahi wabarakatuh. My name is...
After that, substitute r inside the value of h to find h. And then we'll get 3.728. These numbers are rounded to 3 decimal places required from the question. To make sure that the area is minimum, we'll differentiate the area again from here. And there we have it. The value is more than 0, which means it is minimum. So, the area is minimum when r is 1.366 and h is 3.728.
of change of x with respect to y, which is the gradient of the curve on a graph of y versus x. There are a few basic criteria that may be used to
related
quickly discern
rates
and
and
variety
applied
of
maximum
functions.
and minimum problems. Thank you for watching.